So here is the result of that. And it's looking really, really cool. Still room for improvement, but looking very cool. One place that it could be improved is still talking about the disturbance. We can kind of see up here that it's still like tearing those areas apart with kind of the same gusto, see like that, as we have down here. This comes up a lot where we want to target our disturbance in areas that are moving quickly. So basically, how do we put more disturbance in areas that are moving quickly versus others? Well, we can just say, make the disturbance strength be proportional to how fast it's moving. So to do that, let's go look at the solver again. And many of these microsolvers here, like Disturb, have a control tab. So we say, let's use it, control field. And then we've had some field, like density or temperature or whatever, and say ramp in the effect. By default, it's just a linear in from that to that. And we'll kind of multiply the result of that by the strength. So what field should we use, though? Let's just go to one frame in so we can see the fields. Where are my fields? Oh, I guess right, because nothing has happened yet. So we've got active, we've got density, and then by the next frame we should have like velocity and everything else. So velocity is what we're talking about. We want it to be where it's moving quickly. But velocity is a vector field. It's not a single scalar value that we can compare from 0 to 1. And because you remember, velocity is like a direction and all that stuff. Remember before when we took the length of the velocity vector to get the speed? That's what I want. I want to do this in terms of speed. There is no speed field. A long time ago, when I did an earlier version of one of these volumes lessons, I showed you how to bust into the gas disturb in order to do crazy stuff in here. And honestly, you still can do that. You could find the control field here, looks like, and then do that. You'd have to unlock this and then change it, but even that only works on that one. If it's doing in the OpenCL accelerated version, you'll have to like break open each one of these, like the continuous one or the blocks. It's just too messy. So I want to do it a different way this time, which is equally valid, even though it technically takes up a little bit more memory. So what I'm talking about is, let us make a speed field. Simple as that. So I'm going to say gas match field will be how we start here. Gas match field is going to say, take a field that we already know about, say our velocity, that's the reference field, and let's make a new speed field. It's going to be a scalar, meaning not a vector, the thing that's giving us a problem in the first place. So make a scalar speed field, and the reference field just says make it as big as, and the same voxel dimensions and everything else as the velocity. I'm actually going to organize this a little bit better. I'm going to merge here. Let's put our little microsolvers over on this little island of things. And let's also move the gas match field to be first. I want that to happen before we get to the disturb. So this, in theory, should make a speed field. Now, I think in practice, we won't see it. And I believe the reason for that is if the field has nothing in it, it just gets culled out by DOPS anyway. So it created a blank field that has the same size. Remember, it's not copying the contents over. So it's making the same size of it, but that's not too helpful. So that's how it starts, though. So let's imagine, though, that it is creating this field, and then it's just getting deleted. But it does exist at this point. So put a gas analysis down. And once again, the destination field will still be speed. The source is the velocity. But now we can just say length, just like before. Take the length for every voxel, take the length of the velocity, put it into the speed thing. A lot of these nodes I should mention you can use OpenCL on. As we talked about in the sparse lesson, you cannot use OpenCL on sparse, even though it's right here. Because the moment you try to do it, it will error out and say, nope, you can't. OpenCL is not compatible with sparse right now. So God knows why that's listed first and foremost there. That said, you can use it on any of these other microsolvers, like the disturb will let you turn it on. I'm not going to. It does help, but I know later when I'm gonna up-res all of this stuff, when I make my voxel grid size be too big for my GPU to hold it in, it's gonna error out. So if you do turn on your OpenCLs here, just beware. If you get error messages, then you'll have to turn it off anyway. But I guess you can just turn it on now in the meantime. In any case, so I'm going to go back to frame 5 again. Now that both of these are on, I should see a speed field now. Do I have a speed field? There it is. So speed field does exist. Because now the different voxels have different values. It's not being removed by DOPS. So if we really want to make sure that it works, actually put it in here and turn on visualize strength. So now, as we press play, we should see this visualizer here get made like so. That's pretty cool. So now we can see the strength based on the velocity. Pretty rad. So what are we going to do with that? Well, we can keep the 0 to 1, or we can change it up. I'm going to say, let us modify this a little bit. I'm going to say, let's try 0 to 4. And you should see it update here. So now you can see that. So it won't be quite as severe. It has to go faster, essentially, to achieve the maximum amount of disturbance. And that was just for the visualization, though. This has the same range here, so make sure that the actual control range matches it. Sweet. That's pretty much it. Now that there's going to be less disturbance in those small areas, you know, we might not see enough of it. So we may have to run another thing. But the idea here is I want to solve two problems at once, which is I want to have more disturbance, perhaps, in these fast-moving areas, and I want to have less disturbance here. And that's exactly what we'll be able to get. So I'm going to increase the strength by 2 times. So now we have 10 strength, but it will be maybe even less strength than usual in those slower areas. And only the 10 strength will be applied in the fastest moving areas. You can use all the visualizers you want, but the cumulative effect of this we're not really going to appreciate until we actually, you know, run the sim. So let's run the sim. I'll make yet another one of these things. Much, much improved. Hope I'm not running out of disk space. Save that, and let's see. I'll move this here too so I don't forget. I'm going to do it and also make the flip book before I continue.